Hello, geometricians. We're doing more circles today. Yeah, hope you guys are doing all right, hanging in there. And so far I've been really impressed with the things that you've been submitting. Keep it up. Yeah, this stuff puts me a long time to put together, but I think there's good quality problems in here, and I just want to keep you doing some good quality problems. So today we've got 2 warm-ups and no cool downs. Again, I'd encourage you to pause the video, try these on your own. We would spend time in class trying them, collaborating with our neighbors, but do your best to try it yourself. Here are solutions. This first one, the perimeter of a square circumscribed about the circle is 80 inches. This, let's make it fatter. This is the square circumscribed about the circle. And its perimeter is 80, so this is 20. Oh, that's a big fat 20. Wow, let's skinny that up a little bit. Circles are all about where you draw the radius. If this whole side is 20, then this is 10. And where's a smart place to draw the radius of the circle? How about right there? 10. I could draw 2 radii like this. Those are both, the blue lines are both radii of the circle. All 3 of those segments that I drew are actually radii of the circle. They're all 10. And this would be a 90-degree angle. This would be 45, 45, 90. And the length of the square, 10 square root 2. The question is, find the perimeter of the square that's inscribed in the circle. Let's do another fat one, make it purple. This is the square inscribed in the circle, and its perimeter is 40. Square root 2. Label inches. Okay. Circles are all about where you draw the radius. Draw it in places that make triangles. Okay, this one is trickier. This should say the radii of externally tangent circles are 25 and 55 centimeters. Find the distance between the points of tangency. These are the points of tangency. I want to find the distance between those points of tangency. Circles are all about where you draw the radius. I'm going to draw the radius right here and right here. 25 and 55. Okay. I'm going to draw more radii right there. That segment, the purple segment, is made up of both radii. So it is 25 plus 55, or 80. It's the length of both radii. This one is much trickier than the last. Again, I'm trying to find the length of x. I'm going to break that. Right now it was a trapezoid. What I had drawn was a trapezoid, but I'm going to break it into this. These are points of tangency, so they're right angles. I'm going to break that into a rectangle and a triangle. A rectangle and a triangle. If this is 25, then this half is 25, and this half is 30. The whole thing's 55. So I'm going to do Pythagorean theorem with that skinny little triangle right there. 30 squared plus x squared equals 80 squared. X squared, I'm going to get 5500, which means x is 10 square root 55. Our warm-up questions were not easy questions, but that's why you're in the honors class. They're good, tricky little things. Again, big ideas. It's all about where you draw the radius and turn things into triangles. Okay. We are talking arcs and chords. So here's some vocabulary right here. I tried to cram it all in there. Central angle. The central angle, that's the one right here in green. See it? Central angle, it's an angle whose vertex is the center of the circle. I would say in this case it's angle APB, or you could say angle P or angle BPA. But that is the central angle. Central angle, the vertex is at the center. What I like about central angles is the name gives it away. It's at the center, vertex at the center. And then I've got arcs. You can see in my picture right here, skinnier now. I've got a minor arc and a major arc. The minor arc is in red and the major arc is in blue. Minor arcs measure between 0 and 180, and major arcs measure between 180 and 360. And that's what the definition right there says. And then we can name them. You name an arc by naming its two endpoints. So the arc, the minor arc that's red right here, its endpoints are AB. So it is arc AB, and you draw that little arc on top. Starts at A, ends at B. You could call it AB, or you could call it BA. Same thing. Major arc, well, I can't just, its endpoints are AB, but I can't just say AB because then I would think of that little red arc. So to name a major arc, you have to have 3 letters. So in this case, ACB or BCA. The fact that it's 3 letters long means it's a major arc, and I need all 3. That means it starts at A, it goes through C, and ends at B. And then a semicircle is also an arc. Its measure is 180. You also need 3 letters to name a semicircle. Let's try one real quick before we move on. In circle E, find the measure of the angle or the arc named. Okay, the central angle is the measure of the arc. So this is 70 degrees. Arc BC is 80 degrees. This angle in there is 80 degrees. All the way around the circle is 360 degrees. So I could add up 70 plus 80 plus 80 and then subtract that from 360. And I would get 130 degrees, just labeling my picture there. Okay, let's see. Arc BC, 80 degrees. Measure of angle 1, 70 degrees. Measure of AC, how do I know if it's big AC or little AC? How do I know if it's this AC or this AC? The fact that it's 2 letters means it's the smaller one. It's the 150 degrees. AC is 150. If it said ADC, then that would be the bigger one, which would be 210. ADB, let's see, ADB means I start at A, I go through D, and I end at B. I could add it all up, or I could do 360 minus 70. And I get 290. Degrees, all of these are measured in degrees. Arcs are measured in degrees. A little bit later we'll talk about arc length, and that'll be a length like measured in meters or inches, but right now they're all in degrees, and we really tried to emphasize that if you say the measure of an angle, you have that degree symbol there. Okay, here are our 3 theorems. The book breaks them down into words. I'm very visual, so I've got them in pictures and words. Theorem number 1, we got 3 of them today. Okay, congruent chords cut off congruent arcs. If the chords are congruent, the arcs are congruent. And then this symbol, remember in the middle, that's a biconditional symbol, which means it goes both ways. If the arcs are congruent, the chords are congruent. If the chords are congruent, the arcs are congruent. So I've got 2 blue chords and 2 mint green arcs. Congruent chords means I've got congruent arcs. Next theorem. If a diameter is perpendicular to a chord, here's the diameter, and it's perpendicular to the chord. If the diameter is perpendicular to the chord, then it bisects that chord. It cuts the chord in half. Likewise, that goes the other way too. If the diameter cuts the chord in half, then the diameter is perpendicular. That theorem goes both ways. One more. Congruent chords. So I've got 2 blue congruent chords there. Congruent chords. Oh, and the reason I put the arcs out here congruent was because I thought the picture looked kind of weird with those marks being on the chords. But congruent chords are equidistant to the center. If the chords are congruent, then it's equidistant to the center, meaning those 2 right there, those 2 lengths are equidistant. If the chords are congruent, then those chords are equidistant to the center. That is the shortest route to get to the center. And then vice versa. If it's equidistant to the center, then the chords are congruent. Those are our three big theorems for this unit. Yeah, we always made a circle card. I'll find a way to make that happen too. But those are how I like to see them, with the picture and the words. Okay, and then we need to prove them. Prove it to me. Prove each one of these theorems, because that's how you're going to remember this stuff. It all comes back to triangles. So we're going to prove, let's assume that the chords are congruent. That's what I've got drawn in for you. Prove to me that the arcs are congruent. So prove to me that the mint green lines are congruent. Again, it's all about triangles, and it's all about drawing the radii. Draw the radii in smart places. I've got 4 radii there. All radii are congruent. The radii are congruent, so I've got congruent triangles. Triangles are congruent because of which method? Side, side, side. If the triangles are congruent, then I know that all of their corresponding parts are congruent because of CPCTC, which means that these angles, these central angles, are congruent. And if the central angles are congruent, then the arcs that they intercept are also congruent. So you just proved to me that the arcs are congruent. It all comes back to triangles. How about this one? Okay, the diameter is perpendicular to the chord. That's what I've got in here. This is a diameter. I know it's a diameter because it goes through the center, so that's safe to assume it's a diameter. Oftentimes it'll say circle O, and then you know that center will be labeled. Okay, it's perpendicular to the chord. Prove that it bisects. Prove that those pink marks are there, that it bisects. Okay, where are you going to draw the radius? I'm going to draw one radii right there and the other radii right there. What do I know? Well, I know that it's perpendicular and all radii are congruent. And so this point is equidistant to the endpoints, so it's on the perpendicular bisector. Any point that is equidistant to the endpoints is on the perpendicular bisector, so it bisects it. Bisected the chord. One more to prove. The chords are congruent. Given that the chords are congruent, and again I drew in that the arcs are congruent just because I thought the picture was too messy with the chords being drawn in there. Prove that it's equidistant to the center. So prove that those 2 marks are there like that. Again, can you draw in? I've got 4 congruent triangles. Yeah, this would have to be perpendicular because this point is equidistant to the endpoints, so it's on the perpendicular bisector. Those 2 triangles are congruent, and that would be on the perpendicular bisector. The big goal here is that you're not just memorizing theorems, but that you're always able to figure things out. And to figure things out, you're going to draw radii to make them triangles. Okay, let's try a couple problems. We're going to practice some of these, and then the homework is there for you. Okay, let's see. These are a little tricky. I like them. The measure of arc VWX, that's this guy right here. That's what I've got to figure out. Let's see. Well, the chord is 22, and this chord, those 2 purple chords, those lavender chords, are both 22. Yep, they're both 22. 12 and 10 is 22, which means that would have to be 110 degrees. And then the leftover part, let's make it another color. Well, I know all the way around the circle is 360, so 360 minus 110 would be 140. So the measure of VUY is 140. It's okay, they named that minor arc with 3 letters. It's okay to name it that way, especially if you don't know how big it is. Let's see. AD. Well, I know all the way around the circle is 360, so let me start by finding the measure of arc AD. 360 minus 30 minus 105 minus 120 means that arc AD is 105. Hey, that's convenient because arc BC is 105. And those two arcs are equal, which means those two chords are equal, so AD is 21 units long. If they weren't congruent arcs, you wouldn't necessarily know how to figure out how long the chords are. Okay, number 3. Let's see. I've got congruent chords right here. That means these two arcs have to be congruent. That one's 130. 360 minus 130 means that the whole thing, all the way from here to here, whoa, is 230. So each of those mint green ones must be half of it, 115. So PR, 115 degrees. RQ, 115 degrees. I like these because they're like little puzzles to figure out. And we've done so much good work with triangles. So we got this. Okay, let's see. All right, I've got congruent chords, cut off congruent arcs. These must both be 80 degrees. And then I know these two are going to be congruent also. So 360 minus 160 leaves me with 200. The blues add up to 200, so they're each 100 degrees. JK equals 100 degrees. LM equals 100 degrees. And KL is 80 degrees. I like these again because they're like little puzzles and I can figure these things out. So can you. It does say in each one that Q is the center of the circle. Okay, that is good to know. All right, how long is PR? Well, this is perpendicular. That means it's, if the diameter is perpendicular to the chord, then it bisects the chord. So that means that PS is congruent to SR. And I recognize right there, 8, 15, 17, my Pythagorean triple. So PR is 30. Love those Pythagorean triples. Okay, let's see. AC is 8. Again, it's perpendicular. The diameter would be perpendicular to the radius. So AB is equal to BC. And AC is 8. The whole thing is 8. Which means that half of it is 4. 3, 4, 5 triangle. AQ is 5. In number 7, honestly, I am not quite sure what's going on in number 7. I can't tell if the 6 is telling you EF or QE. I do not know. I think it's telling you EF, which would mean that DF is 12. Because they would both be 6. What is it asking for? QE. That would mean that this is 6, and I would do Pythagorean theorem. 12 squared minus 6 squared would equal QE squared. So QE is, QE squared is 108, so it's the square root of 108, which is 6 square root 3. I think that's what they're asking here. I'm honestly not quite sure. We'll go with it. Number 8, one of our last ones. We've only got 2 left. Okay. GMJ, that's a major arc. GMJ is 200 degrees. It should say degrees up there. Shame on them, whoever wrote this problem. 200 degrees. The measure of GK, how big is GK? Well, let's see here. I know that it's a diameter perpendicular to a chord. So it's going to bisect the chord, so those two are equal. And then if that whole thing is 200, then what's left over is 160, which means that this half is 80 degrees, and this half is 80 degrees. So the measure of angle GK is 80 degrees. Okay, one last problem to try. Great job, guys. We got this one together. Sketch circle R with radius length 5 square root 3 and chord XY. Chord XY. That is 5XY. Circle R. The chord is 5 units from R. Find the length of XY. It's all about where you draw the radius. The radius is 5 square root 3. Let's draw it right here. Man, I would love for that triangle to be special and I could just do that in my head, but I can't. I'm going to solve for half this. I'm going to make that little variable W. Five squared plus W squared equals 5 square root 3 squared, the whole thing. That's 25 times 3, 75. W squared is 50. W is 5 square root 2. And make sure I answer the question. The question is XY. XY would be 10 square root 2 units. All right. There we go. And that's what we're doing today with arcs and chords. Remember, it's all about where you draw the radius. And these were our 3 big ideas today. Congruent chords cut off congruent arcs. Chords that are perpendicular to the diameter are bisected, and they're also equidistant to the center. These are the problems for you to try. That's all for now.